Okay, we're going to start today by looking at alpha decay. Alpha decay is when a nucleus loses two protons and two neutrons, which is also known as an alpha particle. So here I've drawn fluorine 21. So it has 9 protons and it has 12 neutrons, which makes it have a total mass of 21. Then it's undergoing alpha decay, so it's going to lose an alpha particle that has 2 protons and 2 neutrons, which gives it an atomic number of 2, a mass of 4. And so what's left over is nitrogen, where I just have all the leftover dots. If you look, I now have 7 dots, which makes it nitrogen because nitrogen is the 7th element on the periodic table. And I now have, instead of 12 neutrons, I have 10 neutrons, which gives me a mass of 17. You'll notice that the mass of the numbers on top on the right match the mass on the left. 4 plus 17 is 21. Same with the bottom. 2 plus 7 is 9. We're not losing any protons and neutrons here. The numbers should stay consistent on each side of the arrow. Okay, so now we're going to do some practice problems. That's just what alpha decay looks like. So I'm asking you to write the equation for the alpha decay of, first of all, uranium-238. So let's go through how we would do this together. First, you cannot write a nuclear reaction in name form. I have to change uranium-238 to symbolic form. So what I'm going to do is put the symbol for uranium, which is a U. I'm going to put the mass of uranium up top, which is what's given to us. And then in the bottom, I'm going to put the atomic number of uranium. Now, where you find the atomic number is on the periodic table. So you have to find uranium on the periodic table. And when you find uranium on the periodic table, you'll notice that uranium is 92. Okay, so we're told this is undergoing alpha decay. So alpha is always a 4/2, and it can either have an alpha symbol like up here, or you can write it as helium. Both of those mean alpha to us. Then we want to discover what is being made after the alpha has been lost. Well, remember the two numbers over here have to add up to the top number. So if I have 238 equals 4 plus x, all I'm going to do is subtract 4 from the 238. So I'm going to get a top number of 234 and a bottom number of 90. So then I go to my periodic table and I say, okay, what element has an atomic number of 90? And when I look at my periodic table, that is thorium. Okay, so that is how I would do this problem. Let's try another one here. And this one, I already gave it to you in symbolic form. So I don't have to worry about converting it to symbolic form. I can just go from here. So I'm actually just going to add it on here. Again, oh, that's an email I just got. Again, this is undergoing alpha decay. And since it's undergoing alpha decay, it's going to be a 4/2. And let's write the alpha symbol this time. Remember, it doesn't matter if you write it as alpha or as helium. And then we want to discover what is left over. So what's left over is 226 minus 4. So that's going to be 222. 88 minus 2, which is 86. Then I'm going to go to my periodic table, and radium turned into radon. And so that would be the equation for the alpha decay of radium-226. All right, this last one, I want you guys to try this on your own, plutonium-240. Pause the video, try it, and then I'll go over it. So pause it now. Okay, you should have paused it and tried the problem. Let's check how you're doing. So first of all, because I gave it to you in name form, you have to write the symbolic form of plutonium-240. So first, the symbol of plutonium is Pu. Pu, you guys stink. I'm so silly, I know. All right, and then the top number is going to be this mass number that I gave you, 240. And then the bottom number is going to be the atomic number off the periodic table. So you have to find polonium on the periodic table, and it is 94. All right, so the plutonium is undergoing alpha decay, so you should have drawn an arrow 4/2 in either helium or alpha. It really doesn't matter which one. I generally prefer alpha than helium, mostly because it's quicker to write, but it doesn't matter what you wrote. And then what else you should have gotten here is 240 minus 4, so that's going to be 236. I wrote the 3 first. And then 94 minus 2, which is 92. And I go to my periodic table, and on the periodic table, 92 is uranium. So that's what you should have gotten for the alpha decay equation for plutonium-240. All right, next we're going to move on to beta.